Let us look at the next question. Question number 56. Gold does not dissolve in nitric acid, but it reacts with a 3:1 mixture of HCl with HNO3, which is nothing but aqua regia, and dissolves in it owing to the complexation of AuN plus ions with Cl minus ions to form a complex AuClM minus M plus N. The value of M and N are respectively. So students, we know that Au is first oxidized by HNO3 into Au3 plus ions, and which is then complex with Cl minus ions to form AuCl4 negative. So if we compare the formula of the complex formed to the one given in the question, we can see that the value of M is equal to 4 and the value of minus M plus N is equal to minus 1. So from here we can see that the value of N comes out to be equal to 3. So the correct option for the respective value of M and N is option 4. Let us look at the next question. Question number 57. Which of the following statements is incorrect? Let us look at the first option. Heterogeneous catalysis is a surface phenomena, whereas homogeneous catalysis is not. Yes, this is correct. In homogeneous catalysis, the catalyst is in the same phase as that of the reactant and the products. So this is not a surface phenomena. Let us look at the second statement. A gas-gas interface cannot be obtained. This statement is also correct. Interfaces are generally obtained when there are at least two phases present inside a system. So gases always form homogeneous phase or a homogeneous mixture, and as such the interface is generally not obtained. Let us look at the third option now. Lower the critical temperature of the adsorbate, greater is the extent of adsorption. This statement is incorrect, students. Species having greater critical temperatures are adsorbed to a greater extent. So option 3 is incorrect. Let us look at option 4 now. In physics option, the adsorbent does not show any specificity as the involved van der Waals forces are universal in nature. This statement is also correct. So we have to mark incorrect statement, and the correct answer for question number 57 is option 3. Let us look at the next question. Question number 58. Consider the following statements and identify the incorrect statement. The van der Waals radius of iodine is more than its covalent radius. This statement is correct. The covalent radius is measured in terms of the II bond length, whereas the van der Waals radius is measured in terms of the non-bonded II distance present in a molecular solid. So the covalent radius will obviously be smaller than a van der Waals radius. So this statement is correct. IE1 of nitrogen is greater than that of oxygen, whereas IE2 of oxygen is higher than that of nitrogen. This statement is also correct, students. Nitrogen has S2P3 configuration, whereas oxygen has S2P4 configuration. So if we look at N and O, if we talk about the first ionization energy, nitrogen has a half-filled orbital configuration. So the ionization energy value for N will be greater than O. But if we look at N plus and O plus, when we're talking about the second ionization energy, so N plus has a configuration of S2P2, whereas O plus will now have a configuration of S2P3. Now O has obtained a half-filled orbital configuration, so the ionization energy of O plus or the second ionization energy of O shall be greater than that of nitrogen. So the statement 2 is also correctly given. Let us look at option 3 now. Electron affinity of oxygen is less than sulfur. This statement is correct. Because of smaller size, oxygen has greater interelectronic repulsions and its electron affinity is less than sulfur. So if you look at statement 4, Na has a positive electron gain enthalpy. This statement is incorrect. Na has a negative value of electron gain enthalpy. So statement 4 is incorrect and we have to select it as the answer for our question. Let us look at question number 59 now. The heating of limestone produces a white amorphous solid A. So limestone, which is CaCO3, when it is heated, it forms CaO and CO2. So the white amorphous solid is CaO. which react with water to form a compound B. So CaO, when it is allowed to react with water, it forms CaOH whole twice, which is white and which is the compound B. Now Cl2 is allowed to react with B to form compound C. So when Cl2 is allowed to react with calcium hydroxide, we know that we get bleaching powder. So which is CaCl2 plus CaOCl2. The mixture is known as bleaching powder. So let us now look at the options, and it is given to us that we have to mark the incorrect statement among the following. So option 1, compound C contains chlorine in two oxidation states, viz. +1 and -1. So the statement is correct, students. In CaCl2, the chlorine is present in a state of -1, whereas in CaOCl2, chlorine is present in a state of +1. Let us look at the second option now. Compound B reacts with dilute acid to form corresponding salt. This statement is correct. Compound B is a base and it will react with acids to form their respective salts. Let us look at option 3 now. When compound C is reacted with excess of dilute acid, chlorine gas is evolved. Students, this statement is correct. When bleaching powder is allowed to react with excess of dilute acid, it liberates chlorine gas. So let us look at the fourth option now. Dissolution of compound B in water is endothermic in nature. This statement is incorrect. The dissolution of calcium hydroxide in water is highly exothermic. So students, we have to mark option 4 as the correct answer to our question. Let us look at the next question. Question number 60. In the leaching of alumina from bauxite, concentration of the ore is done by digesting the powdered ore with NaOH and then later it is reacted with CO2 gas. Consider the major impurities present as SiO2, iron oxides and titanium oxide, and some statements related to them. So in the first statement, SiO2 is leached out along with Al2O3 as silicate and aluminate on reaction with NaOH. This statement is correct, students. SiO2 is acidic and it reacts with NaOH to form Na2SiO3, which is silicate. The Al2O3 reacts with NaOH to form NaAlOH whole 4 or NaAlO2. So this is the silicate and this is the aluminate. So the first statement is correct. If you look at option 2, the iron oxides and titanium oxides are insoluble in NaOH and are left behind as impurity. This statement is also correct. Both these oxides are basic in nature. Titanium oxide and iron oxides are basic, so they will not react with NaOH, which is also again a base, and they are left behind as impurity. This statement is correct. Looking at the third option now, on passing CO2, the silicate is precipitated, leaving the aluminate in the filtrate from which alumina can be recovered. Students, this statement is incorrect. Among silicate and aluminate, the aluminium is an amphoteric species, so it can react with both acid as well as bases. So when CO2 is passed into the solution containing aluminate and silicate, it is the aluminate which gets precipitated. So if we have a mixture of sodium silicate and sodium aluminate and CO2 is passed through it, we'll have a precipitate of Al2O3, whereas the silicate, it remains in solution. So we can see that the third statement is incorrect. So we have to mark the correct statements among the ones given. So we have to mark option 1 as the correct answer to our question, as option 3 is incorrect. So this is it for today, guys. I hope the solutions were clear to you. Thank you.